I'm Anil Kumar sharing with you a question from a subscriber. Let me thank them for participating actively and posting questions. The question here is the distance of a ship from its harbor is modeled by the function d of t equals to minus 3t cubed plus 3t squared plus 18t, where t is the time elapsed in hours since departure from the harbor. Three parts of this question are: when does the ship return to the harbor? Draw a sketch of the function where t is between 0 to 3. Estimate the time that the ship begins to the return trip, right? So these are the three questions for you to answer. You can always pause the video, answer the question, and then look into my suggestions. The best way to answer this is really to factor this equation, which gives you distance with time, and then we'll answer them one by one. So what we're given here is distance with time is minus 3t cubed plus 3t squared plus 18t. Now 3t is common, so you can actually take minus 3t common. So we can write this as minus 3t. So you get a quadratic equation, which is t squared minus t, and 18 divided by minus is 6. And 6, we are looking for product 2 and 3, negative 3, right? So we get minus 3t, t negative 3 times t positive 2. So that becomes the equation in factored form. Clearly we have zeros at minus 2, that is not valid, 0 and 3. So these are the zeros for us. So if you have to sketch it, which is also part of this question, so what we will do here is, so we'll kind of sketch it. Right. So from this graph, this factored form of the equation, we could graph this as this becomes minus 2, which we are not concerned about. Time is greater than or equal to 0. So the first 0 here is at t equals to 0. The second one is at 3. And minus indicates there's a parabola which opens downwards, right? So the path is not really it's a cubic equation. So it's not really a parabolic path. It will be shift more towards the right when we sketch this. So it will be kind of like this. Is it okay? Kind of like this. However, we are not sure when will this peak come, right? So we are not sure about this point. In this region, we see that the points are very close, right? So broadly speaking, we know this for sure that it ends at 3. So when does the ship returns to the harbor? It returns after 3, let's see the units. Where time t elapsed is in hours. So it returns after 3 hours. So that is the first thing. So here we have time in hours. Okay, in hours. Let me write hours here now. And this is distance with time. And the distance in time is more by a function this where time is in hours, and it does not say anything about it. So let's say kilometers, right? Okay. So modeled by distance in kilometers. Let me write here. Okay, fine. So that is how it is going to be. Now the question is, draw a sketch of the function. There it is. Part C is estimate the time that the ship begins to return. Now, ship begins to return when the distance starts decreasing. So that is the time which we need to estimate. Correct? Now, how do we estimate this time? The main purpose of taking this video is the same, and students' question is genuine. How do we calculate it? Without doing through a graphing calculator, how do we do it? So I think the best way is we can take some values, just make table of values, and let's write down t. We know the values between 0 to 3. This part is not very critical. Critical part is midway and thereafter. Are you getting my point, right? Midway and thereafter. So we could check with 1.5, 1.6, 1.7, 1.8, 1.9, and 2.0, for example, correct? So use your calculator to calculate these values. That is my suggestion. And what you can do is you can use any factored form which you have or that form. So let's take some values. So we have minus 3 times, I'm using 1.5 first. Okay, so within brackets, let's put this value 1.5 times within brackets 1.5 minus 3 times 1.5 plus 2 bracket close equals to. So let's write them in decimals. So for the first one, we get a value of 23.6, let's say. So that is distance with time. Now just change this to, so I'm not doing all of them, I'll do just alternate ones or maybe a few. Okay, so let's skip one. So 1.7 for example. Okay, 1.7, and then we'll do 1.7, and let's calculate this value. It gives us 24.5. Let me calculate 1.9 now. So let's go to 1.9. So delete 9. So basically you have to calculate these values to get a good estimate. Okay, so which is 24.4. Now what you observe here is that the value dipped, right? 24.5 to 24.4. That means this could be higher. So it's worthwhile checking 1.8, right? So that is how you can quickly get to the result. That's the whole idea. So now try 1.8. And if you get this higher, then that is your return point, and that's a good estimate. Let's check. So in decimals, we get 24.6, and it's indeed higher. So what we will say here is that the ship returns after 1.8 hours, right? So that is what it is. So 1.8 hours, and the maximum distance seems to be 24.6 units. If kilometers, just put that. So the answer for the third part is that it returns after 1.8 hours. Is it okay? So that is how you could quickly get to the answer. So the good part is we really didn't try many values, right? And we got fairly good result. That's how it should be done. I hope that helps. Thanks for watching, and feel free to post questions. Thank you, and all the best.